Alright, go.
Starch, distilled water, glycerin, and vinegar. These four are the key components to making starch-based biodegradable plastic. All you need to do is add them in the correct amounts and heat them until it forms a thin, translucent substance. That substance is your mold. You can use that mold to shape it into any shape you wish to shape it into, and it should stay in that shape until it finally biodegrades on its own.
Okay.
Starch is the main component for this starch-based biodegradable plastic. Starch is a mixture of amylose and aminopeptide. Both are polysaccharides composed of glucose, with the only difference being that amylose is a straight chain, whereas aminopeptide is a branch chain polymer. Starch is also in our experiment, like I've said before, the most important component. Each of the glucose compounds are held together by a hydrogen-oxygen bond. As you can see over here in this diagram, hydrogen, oxygen, hydrogen, oxygen, hydrogen, oxygen, all of them are being held together. Individually, this hydrogen-oxygen bond is weak, but together collectively in a chain of thousands, it becomes very strong. Very strong. So that's why we'll use vinegar. Vinegar is acetic as CH3COOH, and so when it reacts with water to form acetate ion and hydronium ion. These two ions then go and break up these bonds. Not completely, but partially break up the bonds to turn this long polymer chain into smaller polymer chains. Then, when it becomes smaller polymer chains, it becomes easy for the for starch to dissolve into the material. So then, glycerin can do its job. Glycerin works as a plasticizer. It links all of the broken chains together, making them even longer than it was before, making it more stronger, also making them elastic, and also gives them the added ability to pass through each other. That by passing through each other, it makes it more usable, more versatile, more usable to make as plastic and such. For all this to work properly, there must be a continuous heat supply. This is the structure of cellulose. This starch is made from this starch, as you can see, is made from corn. It can be made from potato, wheat, rice, and anything you wish to make.
One question. First thing you do is you put the starch in the beaker.
It doesn't. It's irrelevant. The manner of putting is irrelevant.
Manner is irrelevant. So you can put anything first.
Yes.
But I've seen while doing practical ways, even using just the starch and the water, I can get this kind of result.
But it doesn't hold together.
Okay.
Because the polymer chain isn't long enough, isn't strong
This
enough.
one, does it hold together?
It holds together. Right now it's still in the wet state right now, but when it becomes dried, when it becomes strong, it becomes way stronger than it was.
So, the color?
This is food coloring. This one optional. You can put it, or you can, if you want to put it, you can put it in there. Yes.
Just
starch.
to color the plastic.
Yes. We colored it to distinguish between these two. Now, starch is made from food substances, but food substances we cannot use food substances to make starch, and starch to make biodegradable plastic. That's just uneconomical. We can't use it. That's stupid. It's uneconomical. We are already importing so much food from India and such. We cannot just afford to use them for making bioplastic. So we'll use cellulose. Cellulose is the most abundant naturally occurring polymer in this planet. It comes from trees, and all plants make cellulose. This cellulose, let's concentrate on the CH2OH molecule. Over here it stays up, over here it goes down, over here it goes up, over here it goes down. It changes its direction alternatively, as you can see. Whereas in amylose molecule, it all stays up. It all points to one general direction. So scientists have found a new way. Scientists have found an enzymatic path to turn cellulose into a starch. This starch, as you can see over here, the hydrogen-oxygen bond, they can be using phosphate ions and such. We can break them, individually break all of them, thoroughly break them, and turn this polymer chain into a set of monomers. But monomers don't stay as monomers; they want to become polymers. So these monomers, under specific conditions and such, we can turn these monomers into a polymer. This polymer. We don't want it to be this polymer. We want it to be this polymer. After turning into that polymer, we can use that polymer to make this starch. This starch will be used to make biodegradable plastic. The recent ban of plastics in Bhutan has created huge. Many shops started using these paper bags and such, but they're not useful at all. They're very fragile and such. They also cannot store much, and they're not as versatile as plastic bags. Another alternative could be cloth bags, but cloth bags are just too expensive. Just hard to get, hard to keep around with you every time you go. You can't have a cloth bag every time you go around to towns and like that. So there's a market vacuum right now. Market vacuum which we can exploit and which we can fill using biodegradable plastic. But remember, this is not any biodegradable plastic. It's starch-based biodegradable plastic. Other countries also use biodegradable plastic, but they use PLA, polylactic acid. So polylactic acid, when it decomposes in large number, when it decomposes, it creates lots of lactic acid. Lactic acid, little bit of lactic acid is not harmless. It doesn't do anything. But too much lactic acid can be really bad for the environment. It will pollute the environment, so it has a negative impact. But our starch-based biodegradable plastic is neutral, completely neutral to the environment. It doesn't affect the environment at all. And another added thing is, this one is actually a long chain of this, long and strengthy chain of this polymer. So we can, through another enzymatic part, we can
try. Right now you have used starch. So did you try in other way, like the one you explained from cellulose?
Cellulose we cannot extract right now currently, because we do not have the materials required. We need to have phosphate ions and such. We cannot get them here easily.
You have not tried yet.
Yes, we can get them from China.
We export things.
No, import.
Oh, sorry.
Yes, but another cool thing about the phosphate ions is when you use it once, it'll rebalance itself. It'll rebalance itself, and it can be used many times, over and over again. So this phosphate ions, the phosphate enzyme can be used over and over again.
Can we, we know that we usually get the sap from trees, rubber. There's lettuce.
You won't use that.
Can we use that for making plastic?
No. We won't use that. We will use just basic cellulose.
Why don't we use that rubber? I feel like if we use that and if we add, like you said, vinegar and glycerin and all, I think they can also be turned into plastics.
No, those are resin. Resin can be are used for other things, but not this. I did not try to research also much, so I don't know that in depth. But yes. So this another cool thing is this is a very long chain of this. This is starch, but it's elongated and longer, stronger chain of this. So if we use enzymes and break this down, we can make more starch. That starch can be used to make more plastic. So this plastic is renewable. You can make it again and again. You don't have to always depend on one source of plastic. Thank you very much.
Thank you so much.
All right, just one question. If, all right, you call it biodegradable plastic. Now, let's say I threw the plastic away somewhere. How long would it take to decompose?
15 days.
15 days.
Minimum of 15 days, and it depends on the plastic. If it's a plastic bag, it should take only 15 days because plastic bags have higher surface area and such. But this time, if you make a compressor ball and such, then it might take longer.
You know, bro.
Like last time you explained that this starch, because it's a starch, it's a food material. You said that this is going to decompose so quickly, but seriously, it will take 15 days.
Yes.
I feel like this will decompose before 15 days because you're using food starch.
Food starch is actually strengthened starch because of glycerin and all. It has been strengthened, so it takes a minimum of 15 days. Because all you need to do is break the hydrogen and oxygen bond, so it's relatively fast.
Break that bond.
No, break the bond is very fast actually. But to do all of them, to get all of them, entire thing will take 15 days.
Thank you.
Are you a chemistry teacher or something?
No, I'm
Then-
biology.
Oh, biology.
Yeah, I took both actually, both
Okay.
chemistry and biology, but I'm teaching biology.
Alrighty, so that's why you have such intelligent questions to ask.
No.
Alright, I have one question to ask you.
Let me see if I know.
Alright, what's your number?
That's a different question.